like to start with a question about what is actually a successful MCP server. For that, I would like to take a step back and actually try to define what would be the key metrics that we'll be looking at in order to define success of an MCP server. And I want to do that using parallels with the existing tech ecosystem. Business onlines already have endpoints, already have UIs that allow users or third-party software to consume their product and consume the services. For those users, for those third-party software, we are using Net Promoter Score, for example, for users, or the integration time or the latency of API for third-party software. I would like to come up and define some key metrics for agents that are consuming those services and those products using MCP servers. And the one I'm proposing is the task completion rate. So the quantity of tasks that a user gives to an AI agent using your MCP server that are able to complete, that are able to make the user happy with the end results. Task completion rate is a proxy metrics for the agentic experience quality, what we will call AX experience, AX quality throughout the rest of this talk. Task completion rate, or agentic experience quality, is very hard to measure in production. The first problem that you have two main problems, but the first one that you have is, as an MCP server developer, as a producer of an MCP server to be consumed by AI agents, you don't have the full picture. You don't have access to the underlying conversation that a user is having with an LLM that is requesting tools used from your MCP server. So you're missing part of the conversation, and using only your MCP server interactions that any LLM has with it, you are very not able to say if the task was indeed completed or not at all. Second big problem that you have when you want to start measuring agentic experience quality is the disparity of LLMs that are out there. Here on the left, you can see an extract of the Berkeley Function Coding Leaderboard, which is basically a leaderboard that ranks LLM based on their ability to handle tasks using tools. And you see that this leaderboard is going from 18% for the worst performing LLM up to 78% for the better performing LLM. So depending on who is actually, what LLM people are actually using, results that they will get in terms of task completion rate with your MCP server will greatly vary. In addition to disparity in models, you have also disparity in clients. Depending on which client user are using with your MCP server, they will benefit from features in addition to tools that may help them in achieving their task, but not all those features are available in all clients out there. Facing those two main issues, we have to come up with another set of metrics, proxy metrics, that will give us something more measurable that we can measure and try to improve to make our server more efficient. Those proxy metrics, there are 4 of them. 2 that you can actually measure in production, and 2 that you need to measure in controlled benchmark during your software development lifecycle. The 2 that you need to measure in software development lifecycle are the tool accuracy and the parameter accuracy. So at what point, given a scenario that you predicted, a model is capable of calling the right tool with the right set of parameters from your MCP server. 2 that you can measure in production, which is basically what we call cost in terms of consumption of token, consumption of context window. The more token your MCP server outputs every time it interacts with an LLM, the more context window you consume, and the less chances you have to actually complete the task at hand. And latency, or the quantity of interactions that you have between an LLM and your MCP server. The more interaction in a stochastic system, the more chances you have to diverge from the optimistic path, and the more chances you have not to complete the task by the user. So those 4 proxy metrics are the one we will measure to try to improve the agentic experience. For the accuracy, more is better, and for cost and latency, less is better, of course. Throughout the remainder of these talks, I will assume this following parameter for the benchmark I will present. You may end up with different results. Remember that the results I will present today are more information about direction and impact of modifying those parameters, rather than exact absolute numbers of what works and what doesn't work in production. There are, as an MCP server developer, 3 locations you can act upon on your MCP server, which are the 3 interfaces that exist between an LLM and your MCP server. We'll take a look at the first one, the tool list, which is basically what a model calls whenever it connects to your MCP server to get a full sense of what your server can do. The first thing that we can act upon is a quantity of tools that our MCP server returns to the LLM. The quantity of tools has an enormous impact on tool accuracy. The benchmark results that you see here are actually using the same task, but increasing incrementally the quantity of other tools available to the LLM to see how it performs selecting the correct tool every time. And you can see that very, very quickly, on a logarithmic scale, above 20 tools, we get below 50% results of selecting the actual tools that we need to use for the task at hand. That's why you see a lot of clients out there, especially Cursor, for example, that is limiting the quantity of MCP server that you can connect to 40 tools to avoid this phenomena of having very bad tool selection accuracy. A very popular pattern that we see, and that doesn't really play nice with this first observation, is the one-to-one wrapping phenomenon that we see in MCP design, where you take your existing API and you basically put one tool on top of each of the endpoints of your existing API. Problem is, most of the time you have multiple endpoints, which ends up being multiple tools, which greatly increase the quantity of tool and decrease significantly your task completion rate. Another thing we can change, instead of increasing the quantity of tool to improve the quantity of functionality you can expose via MCP server, is increase the quantity of parameter to allow for larger polymorphism within the same tool. And increasing the quantity of parameter, using the same benchmark I was showing before, has a much better impact on the various proxy metrics that we're using to measure the agentic experience. When you increase the quantity of parameter, you only linearly reduce the tool use accuracy. So there is another pattern that emerged from this behavior, from this measure made in production, which is a pattern that became popular, was made popular by Block, the company behind Goose, if I remember well. It's called the layer tool pattern, which basically is an extreme representation of polymorphism. For each server out there, it only requires 3 tools to be available. The first one to discover the various services, the various domains available on the server, payment, catalogs, products. The second one for a specific domain to list the available tool to be used with their corresponding schema. And the third one, which is a generic execution tool that allows you to, for given domains and for a given tool with a given set of input, ask the MCP server to complete the corresponding execution. Virtually, with this pattern, you can expose as many functionality as you want, and you only remain with 3 tools. And you really need to strike a compromise in between the first pattern that I was showing, the one-on-one API wrapper pattern, and this extreme pattern of polymorphism, because what you gain in reducing the decrease of tool use accuracy with polymorphism, you lose in the quantity of interactions that are required between your client and your MCP server. So for one interaction, you need 3 back and forth between the model and the MCP server to be able to execute one tool. As you're always in development, it's always a balance in between various aspects that you can implement in your MCP server design. And I would suggest striking somewhere in between the single responsibility design pattern and the polymorphic layer tool pattern. Of course, tends to be more on the polymorphic side because it is a less decrease of tool use accuracy when you're polymorphic rather than adding new tools on your server. What's best at the end of the day is trying to design tools not as endpoints available on your API, not as the 3 tools of the layer tool pattern, but rather as agentic experience, agentic user stories, complete feature set that is packaged into a single tool. Like, for example, the push files tool from GitHub MCP server is actually encapsulating 3 various API, creating a new branch, committing changes, and pushing the branch on the remote repository, which is a full feature that as a developer you may want to use with the MCP server. And you don't need to call those 3 tools separately. One last thing you can do on your list of tools available when you first broadcast the various features that are doable with your MCP server is have impact on the schema definition of each of your parameters. For example, you could, if you need a booking date as an input from the LLM, choose to request a booking date in the format of a timestamp, in the format of string, or in the format of an ISO 6801 in order for the tool to be able to accomplish its task. What we've seen for this is you have much better tool selection and parameter selection accuracy when you're very close to what the end user is actually using. For example, you have better chances as a user to give a date that looks more like September 22 than a timestamp. There is no chance that somebody in this room knows by hand, knows by heart the actual timestamp. So it's better to expect from the LLM to be called with a date in ISO 61 or in plain text. Same thing if you're requesting an interest rate as an input parameter of your MCP server, rather than using a numerical statistically correct value like 0.03 for a 3% interest rate, expect 3. And you can even say in your parameter name that you're expecting % value to make sure that this is closer to what the user would actually input in a conversation with the LLM. Okay, so that was for exposing your feature sets through tool listing. Now, what you can do as an MCP server developer when being called to be for a tool to be used is actually have an impact on what you return to the model. And the first thing you can change is what you return when the tool use is successful. Here is, for example, an extract of the API from Stripe when you create a new plan on their API. You could, for example, take this JSON and stringify it and return it as is to the model. But we saw a great improvement in performance, especially in context window usage, trying to remove redundant information and not very useful information. If you don't want to flood the context window of LLMs that are actually calling your tools, remove everything that is a duplicate. You have amount and amount in string, for example, on the Stripe API. You don't need those 2 formats that was made initially for programmatic access to have directly the right value at end. You can always strip one of them and remove everything that is null or empty object that will not add context to the model calling this tool. There is also something you can do when returning something to the model after a failed execution of a tool. Instead of just returning an error occurred, which is something that you would usually do developing front ends or API endpoints, you can actually have the certainty that the model will do something with the error you're returning. So it's better to give them tips on what they can do to try to make the call have better chance of success. For example, if you're providing an MCP server to handle infrastructure and somebody is calling a tool trying to delete some piece of infrastructure that needs to be stopped beforehand, you can say in your error message in plain text that the resource that is being tried to be shut down needs to be stopped beforehand. If you have an input validation error, like the model is calling your tool with a wrong date, which is in the past because the model still thinks it's in 2024, you should put in your return response that you are currently in 2025, that this is the current date, to give the model a better chance to try again the same tool call with the correct date this time. Final location where you can have an impact as an MCP server developer is for the tool list notification of change. This is a feature that is part of MCP protocol that allows you during the session to change the list of tools available for a model to be used. I would suggest not to do anything with this feature. Problem is most model provider out there tends to rely on cache, using tools available for the conversation as a mechanism within the construction of the cache key of the model. So if you change the list of tools mid-session, you have chances of invalidating cache available for the remaining conversation for this model provider. So what we see to improve the agentic quality of your MCP server. During tool list, prefer less tools with more parameter. prefer polymorphism and try to package your tool as full user experience rather than individual interactions that they can do. When when tool use is being made, try to remove any redundant and non-relevant information from your response and leverage meaningful error message to allow the model to retry the tool use and try to be successful this time. And do not use any notification of tool list change. Another good thing to improve the agentic experience is to rely on other primitives of the MCP protocol, not only on tools, like, for example, relying on resources and prompts that give back to the user a bit of control on the context of what it really wants to achieve, which usually remove some stochastic steps in the middle and improve, in some cases, the experience that you give to the user. You can also rely on elicitation as a way to capture additional context from the user during the tool execution in order to improve the quality and the task completion rate of your server. All these proxy metrics were shared with you after using some bench tool from the open source community. I give a few here. I will give you a little bit more details about the one that we are developing at Alpic, which is called MCP eval, which basically allows you to write unit tests that you would like your model to perform well with your MCP server, with expectation of tool call with exact parameters. You can then run those tests with environments that simulate what you will find in cloud, so basically system prompt, models, and available tools that are not part of your MCP server, like web search, in order to check that in those scenarios, you have better chance of having the model behave as expected. Another thing that you can do with what we provide at Alpic is measuring in production the average output token of your MCP server and the quantity of interaction per session and per typology of clients. So all these metrics at hand will allow you to develop better servers. If you want to learn more, we're also doing hosting and various other things at Alpic. I'd be happy to tell you more about it if you want after the talk. I give you some links in case you want to get this presentation, connect with me on LinkedIn, or want to discover more at Alpic. I'd be happy to have a conversation. Thank you for your attention, and have great beers.